short video explaining how to turn a decimal number into a hexadecimal number. Now there's going to be two steps we do here. We're going to convert our decimal number into a binary, and then our binary number into a hexadecimal number. And that's just because it's far easier to do that than trying to do the calculations in your brain to do straight decimal to hexadecimal. Okay, so how are we going to do this? Let's start by learning a little bit about hexadecimal numbers. The hexadecimal number line goes from 0 to 9, and then for values 10, 11, 12, 13, 14 and 15 we substitute the letters A to F. Okay, so that means A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So with 0 to 15 in our number line, that gives us 16 individual values, which is how we get that hexadecimal referencing name. Okay, so we're looking at, say, converting 96, which is a binary number, a decimal number. And we're going to look at now converting 96 as it is, or as it stands, into a binary value. So how do we do this? Like everything else we've been looking at today, obviously to convert it into a binary, we need to work our way through looking for which column's value is the greatest number that is less than or equal to whatever total we're aiming to get. So at 96, which value will go 64. Then in order to work out what we've got to do, what we've still got remaining, 96 minus 64 gives us obviously a value of 32. Then 32, what's the largest value column that is less than or equal to 32? Of course, it's 32. So 32 minus 32 equals 0. So just to check we're right, if we add up 64 plus 32, hopefully we get 96. 64 plus 32, we do get 96. And then what we need to do is we need to fill any of the columns to the right with zeros, just so all our value columns line up. So 96 in decimal as a binary number equals 11000000. 11000000. I'll put a 2 there because we then know that that means that it is a binary. So we've done half of our equation so far. We've been able to convert the decimal number into a binary number. The next thing we need to do is convert our binary value into a hexadecimal. And the easiest way to do this is as follows. If we write out that binary value here, and we want to now convert that at some later stage into a hexadecimal number, here's what we need to do. We need to split our binary number into lots of 4 digits. So if I had to take this number here and I'm going to split it into groups of 4, I always work from the right hand side. So we go 1, 2, 3, 4. So I'm going to put an imaginary split there. And 1, 2, 3. If you don't have quite enough in blocks to get to 4, you can have leading 0. So I'm just going to add a leading 0 there. So all I've done there once again is I worked from the right hand side and I divided my binary value into lots of 4 bits. If I had less than 4 bits in a package or a parcel, I'm going to add a leading or a starting 0 because it doesn't change the value then. The next thing we need to do is we need to work out the value in decimal of each of these lots of 4 bits. So if we look at the value of this, I'm just going to remove these temporarily. So 0, 0, 0, 0, if I add up all those columns, what value does that equal? Of course, if you can tally like I can, that's going to give you a total of 0. Okay, now I'm going to do the value of these 4 digits. So we've got 1, 1. So we've got 0, 1, 1, 0, 0, 1, 1, 0. So if I tally that up, so that's a 4 and a 2, so that gives me a value of 6. Okay. Now what I need to do is I need to take these 2 decimal values and work out their equivalent in hexadecimal. Now remember we already said that if the number's 0 to 9, it remains as 0 to 9, but if we get values 10, 11, 12, 13, 14 or 15, it's going to change to a letter respectively. In this case, 6 in decimal equals 6 in hexadecimal, and 0 in decimal equals 0 in hexadecimal. So our actual answer ends up being this, that 11000000 in binary is the equivalent of 6 and 0. So what we did here is we just joined those two numbers together. We didn't add them, we didn't multiply them, we just put them side by side, and then we indicated that we were talking hexadecimal by using the subscript value of 16. Let's try a different one that might be a little bit more complicated just to see if we understand. So, if I say that is a decimal number, sorry, that is a binary number, and I want to work out what that value is in hexadecimal. We'll do exactly the same process we did before. So the first thing we're going to do is we're going to chunk it into groups of 4 bits. So I'm going to type the number again. And starting from the right hand side, I'm going to count 4 bits. 1, 2, 3, 4. So I'm going to put a big space in there. 1, 2, 3, 4. Excellent. The next stage of this was then converting each of these lots of 4 bits and working out their value. So if I made this 0, 1, 0, 1, 0, 1, is that what this is here? Perfect. So if we add up the values, 4 and 1, so that's going to equal 5. At this stage, that column equals 5, or that block or that package. Now we've got this one, so we've got 1, 1, 1, 0. So, 1, 1, 1, 0. So the value of this block of 4 bits is going to be 8 plus 4 plus 2. 8 and 4 is 12 and 2 is 14. Okay, so now we have our binary number broken up into banks or packages of 4 bits, and we've worked out the decimal equivalent of each of those packets. Now we've got to convert that decimal value into a hexadecimal value. Remember, if the decimal value is 0 to 9, then our hexadecimal value retains that same number. So 5 becomes 5, but 14 becomes a little bit different. So 9, A equals 10, B equals 11, C equals 12, D equals 13, E equals 14. So this is actually going to say a capital E. In the last stage of this, we just put this all together. So E5, I'm just going to make that subscript once again. E5 as a hexadecimal is equivalent to that binary number. And if we wanted to, we could always convert that binary number to work out what that is in decimal if we were to put these values in that convert column. But that's how you take a binary number and turn it into a hexadecimal number.